Assalamu alaikum. We are starting with the remainder and factor theorem, which is chapter number 5. Over here we have a given polynomial. A polynomial is any expression which has terms in the value of x. Over here we are using a sign that has 3 lines instead of 2 lines for the equals to sign. You don't need to get confused by that. This is the same thing. This just stands for identities. You don't need to get confused by that. Just this and the equals to sign are the same thing. But in the remainder and factor theorem, we use this sign to denote this expression. Now, if I want to find out A, B, and C, what will I do? So, firstly, let's try out finding C. Because C is isolated, C is alone, C has no factor, no coefficient, no multiplying value with it. So we'll try to find out C first of all. So over here, if you see x minus 1 and x minus 1, you have the same bracket, the same term over here with A and with B. So we are going to equate x to 1. If x is equals to 1, then what happens is that 1 minus 1 becomes 0. This bracket becomes 0. So this whole term is eliminated because if you multiply anything with 0, the answer is 0. So over here, this whole term becomes 0. Again over here, x minus 1 is equals to 0. 1 minus 1 is equals to 0. B times 0 equals 0. We have another value that is eliminated. Then we have C left. This term was eliminated, this term was eliminated, only C is left. C equals x cubed minus 2x squared plus 5. Since x is 1, we will replace 1 with x. So it becomes 1 cubed minus 2 times 1 squared plus 5 is equals to C. So when we calculate all this, C, the value of C comes out to be as a 4. Now that we have C, we can try to find out B because it's the next easiest term. So we will try to eliminate A now. This whole term we want to eliminate this term now. How are we going to eliminate this term? We are going to take, we have the value of C as 4. So the next thing we do is to find the value of B, we are going to equate this to 0. How? We are going to take x as 0 now. When x is 0, nothing happens to C, nothing happens to B because 0 minus 1 times B becomes negative B. So the B is not eliminated. Over here, when we take x as 0, A multiplied by 0 becomes 0 and this 0 multiplied by this whole bracket becomes 0. So the value of this term that contains the A is also eliminated. Now we can express this in the form B 0 minus 1 plus C, which is 4. So when we have this, it becomes negative B plus 4, and that can be equated to this expression. We're going to replace the x with 0. This term becomes eliminated because 0 cube is 0. We'll put this x, this value of x again over here. So 2 times 0 square becomes 0, and so this is equals to 5. When this is equals to 5, the value of B will come out as negative B is equals to 5 minus 4, B is equals to negative 1. We have the value of B as well. Then we need to find out the value of A. Since we have the value of B already and C already, let's replace them. C is 4, B is negative 1, we can put any value for x to find the value of a. When we're going to take the value of x as, for example, 2, because over here we can take x as any value since we have b and c, and this whole expression is satisfies every single value of x. The question will always mention that this whole equation is satisfying every value of x. No matter what we put for x, if we take x as 1 or 0 or 2, we will get the correct answer. So, when we're going to take x as 2, this becomes 2a multiplied by 2 minus 1 whole square minus 1, 2 minus 1 plus 4. And in this manner, if we equate this whole expression to this expression and we replace the x over here with 2, the value of a will come out to be, so a is 1 over here. We have all three terms, a as 1, b as negative 1, and c as 4. And if we replace them in the original term, you will see that we will get this whole expression, which shows that this equals to sign with 3 lines is fulfilling the whole equation. Now, theorem. Let's have a look at this equation. This x cube minus 2x square plus 3 is an expression that can be termed as the function of x. So this whole polynomial is a function of x. You don't need to get confused by that. That's just a way of expressing this polynomial. So if we need to find out the factors of this expression, what do I mean by a factor? If I say that any expression, for example, if I say that x plus a completely divides or is a factor of this polynomial, I mean that when I'm going to divide it, the answer I will get will be 0. The factor theorem states that when a function of x is divided by a factor a, the answer will be 0. So when I say that x plus a is my factor, I'm going to equate my factor to 0, which means that x plus a is equals to 0, and hence x becomes negative a. So my factor is negative a. I'm going to put negative a in place of x because x is equals to negative a. So I'm going to replace my x with a negative a, and the answer I will get would be 0. So what if we want to find out the factor of this expression? We're going to do it by the trial and error method. We're going to start with 1, then negative 1, 2, negative 2, 3, negative 3. In your exams, it will not go further than that. So through the trial and error method, if I replace x, if I say that my factor is x plus 1. So what does my x become when I equate x plus 1 to 0? My factor becomes x as negative 1. Hence, x is negative 1, so I'm going to replace this function of x. This becomes negative 1. So I'm going to replace all my values of x with negative 1. I'm going to replace this x with negative 1. And since you've studied the chapter of functions, you can easily replace this with negative 1. Now when you try to find out the value of this expression, the answer is going to be 0 through simple mathematical calculation. So if this is equals to 0, it means that x minus 1 is a factor of the following expression. That being said, we've now understood that any factor, any expression that is a factor of a polynomial will always equate the polynomial to 0. X minus 1 is a factor of x cubed minus 2x squared plus 3. The answer we will get when we replace the x with negative 1 is 0. That is the factor theorem in a nutshell.